Hi and welcome. Today we are going to talk about buffers. Now buffers is a very important topic in chemistry and you will hear a lot about it. We're going to be talking about preparing buffers, what kind of pH you want with a buffer, but what actually is a buffer? Buffer solutions are very important and in fact can be found all over out in nature. Human blood, for example, is a buffer system. It maintains a pH within a certain range with additions, small additions of acids and bases. It keeps that within that pH range. Now, a buffer system is an acid, a weak acid, with its conjugate base, or a weak base with its conjugate acid. The amounts of these acids and conjugate base or base and conjugate acids need to be comparable in order for the buffer solution to work as intended. Now, you may be asking, why do you have to use a weak acid or a weak base, and why can you not use a strong acid or strong base? And the reason for that is the amount of dissociation that you get with acids and bases. Strong acids and strong bases, if you'll remember, fully dissociate in water, which means that they are going to readily donate hydroxide and H+ ions anywhere they need to go. And so they don't make good buffers. As a matter of fact, if you combine a strong acid and a strong base, what you're going to get is a neutral solution with salt. So if you add equal amounts of an acid, a strong acid, and a strong base, you're just going to get water and salt. That's all you're going to get. And that's why we can't use these for buffer solutions. But weak acids and weak bases do not fully dissociate. Only a fraction of those acids will dissociate in water, leaving another portion of that acid undissociated and able to react with an addition of its conjugate. And that helps it stabilize the pH. Now, I'm going to turn the camera around for a second. We're going to talk about the Henderson-Hasselbalch equation. If you don't know about this equation, you really should, take a look into it, take a look at how it's written. I have seen problems in the past where this equation has been completely turned around and you have to solve for any and all variable in it. And so you really need to be comfortable with working this equation, rearranging this equation, and solving this equation. Hasselbalch equation. The pH is going to equal the pKa plus the log of the concentrations of the salt over the acid or the base. Now, what do I mean by salt? That is just its conjugate. When you mix an acid and a base together, you get a salt and water. And it's just easier to put a salt there rather than put the conjugate there. It just makes it easier for me to remember. But you could write, the conjugate of, so the conjugate acid is going to be your A- over the concentration of HA. So this is the generic acid and this is its conjugate or its salt. So you could sub that in if that makes it any easier for you to remember. Just remember, when you're doing problems with bases, you're going to have the base's conjugate acid over the base itself. Now, this bottom equation is also one that you're going to need to know how to work, that you should honestly have already seen several times at this point. Your pKa is going to be equal to the negative log of your Ka. Now, we know that Ka is the acid dissociation formula, and so now if we know our Ka, then we can solve for our pKa in order to plug it in to this Henderson-Hasselbalch equation, and that's going to be very important for some of the problems that we're going to have to solve in this section. I am going to post this video and then I'll post some videos working some problems in just a moment.